Welcome to this year's ARF in Finance Conference. My name is Gib Bassett. I'm the head of the Finance Department here at UIC, and it's our great pleasure to host and be the location for what has become an incredibly successful series of events. I would like to acknowledge the planning committee who has put together the program for this year. You know many of them already. In case you don't, I'd like them to just stand as I just have them be acknowledged. They said to me, if you haven't met them over the next 2 days, you should not hesitate to come up and introduce yourself. I'd like to mention Dirk. Is Dirk in the room? Dirk is over here. Jeff Ryan is back over there. Peter Carl is over here. Brian is way in the back out there. Josh Ulrich is way over here. Dale Rosenthal was right there. I think there he is in the back. John Miller is another one of my colleagues who has helped put on this fantastic event. I also just want to briefly acknowledge the person who without whom we couldn't do this, and it's Mary Deering, who many of you have already met, and she has just been fantastic in helping to put this together. What I'd like to do is introduce the Dean of the College of Business Administration from UIC, Dean Mike McHale, to say a few words of welcome. Mike.
Good morning. I won't keep you. I know you guys want to get started. I just want to say welcome to UIC. Over the 5 years I've been here, I've seen this conference grow quite a bit, and to me that says that you guys must be doing something right. The one thing that hasn't changed over the 5 years I've been here, though, is that every time I've come up, I've had to apologize for the weather. So for those of you who aren't local, I could stand up here and tell you that the last few days were amazing. I was at a couple of Cubs games this week. It was sunny, warm, but it's always hard to believe because I think almost every year when we've held this conference, it's looked like it does right now, gray, wet, cold. But nevertheless, that'll keep you guys indoors. I know you guys have a lot of great presentations, and so I hope you enjoy the program, and it's good to see you here. Take care.
Thanks, Mike. I'd like to now introduce Peter Carl from the Planning Committee to say a few words about another set of organizations without whom we couldn't do this, namely the sponsors of the conference. Peter.
Before I get started on the sponsors, let me just say thanks to all of you guys again, and add my thanks that you're here. Whether this is your 9th year with us or your first year, we hope you feel welcome and encourage you to reach across the table. I think that half the conference is just in being with this crowd and mingling among it, and it's a great crowd, so we've enjoyed it very much. Key partner for us is UIC, steadfast since the beginning. Thanks again, Gib. We really appreciate your efforts in all of this. And I just want to pile on and say thanks to Mary Deering and the staff again. They've been absolutely invaluable. I want to point out that UIC does offer a master's degree in finance for both the full-time and part-time formats. One of the attractions of their program is the CME Trading Room, which is a lab where R and other software is used to enhance student learning and encourage research. All the UIC students with us today are proficient in R. Many are graduating or heading to local trading firms, rating agencies, and other statistical consultancies. As graduating students present enormous potential value for somebody looking to make a good hire, I would encourage them to reach out to the people you're meeting today and talk about what various firms are doing. Revolution Analytics is returning for their 9th year as a sponsor, now disguised as Microsoft R. Microsoft R Open is the enhanced distribution of open source R from Microsoft. Enhancements include multi-core processing, fixed CRAN repository date, reproducible R with the checkpoint package. I want to point out, though, Microsoft is providing the videotaping this year I know that there are a few opt-outs, but in general, I think most of these presentations are going to be available online. I also want to, if you want more detail on that, find David Smith. David, and he can give you more details on that. So thank you to you guys. Glad to have you back. RStudio is another returning sponsor this year. They provide open source and enterprise-ready professional software for the R statistical computing environment, including the RStudio IDE, which I use myself, web application framework RStudio Shiny. They actively support the work on several open source software projects that enhance R, including Knitter, Plier, DevTools, lots of other stuff. Make sure to stop by and talk with the team at their table in the sponsors room. Interactive Brokers is back again this year. So they're the largest electronic brokerage firm in the world, likely well known to this crowd because of their scalable, cost-efficient platform, low-cost brokerage. Although they're known for quality execution, competitive rates, real-time risk management tools, and comprehensive reporting, you probably know that they operate with an open API, and maybe you're using Jeff Ryan's iBroker package that's up on CRANs. Stop by their table to ask for more detail. Last but not least is William Blair Investment Management, a global asset management firm with over $60 billion in assets under management. Their investment teams are solely focused on active management, and they employ disciplined analytical research processes across a range of strategies, including some U.S. equity, non-U.S. equity, fixed income, multi-asset, and alternatives. They are active users of R, and their unusually handsome quantitative group is in the audience today. Swing by the table, say hello, and if you don't already have one, pick up a copy of Paul Teeter's R Cookbook. Ask him to sign it. We're very glad to have these firms as sponsors this year. We think they each bring something interesting and useful to the R Finance community. We deeply appreciate their support for making R Finance possible and hope that you stop by the sponsors room to visit with each of them. One last item of business is that we do have a couple of slots open for tonight's dinner. So if you're interested and haven't signed up, I would encourage you to do that. See Mary Deering afterwards. Thanks again to the sponsors. Let's have a nice round of applause for those guys for helping make this all possible. So we're going to launch right into it. We're going to go right into the lightning round. So we'll get started here in just a moment. Okay, so we're going to kick this off with Marcelo Perlin. Marco, you want to get started with the Get HF data. Just a reminder on the rules of the road, 6 minutes, and look for cues from me.
Okay, thank you very much. My name is Marcelo. I am an assistant professor of finance from south of Brazil, and I want to say it's a great pleasure to be here and be talking a little bit about my package, which is Get HF data. So before I start out, one of the problems that we have, at least when I'm advising PhD students, is about the difficulty of handling financial data when you change the frequency of it. So one of the first things we learn is daily data is quite easy to handle, and the same for monthly and yearly data. But when you start working with high-frequency data, then gets really difficult, right? So what is the problem? The problem is intraday data, tick-by-tick data, trade-by-trade, or quotes. These are very large files, right? And they're usually separated by day. So even if you look into a not-so-liquid market, such as the Brazilian exchange, you know, the size of it just gets really complicated very easily. So one trading day is around 600 megabytes. So if you look at 1 year of trading data, which is quite reasonable for academic research, then you start to get more difficult. So for someone to use this, you must learn a couple of packages. You must learn how to load this data into computer's memory and so on. So you must have some training in software. But at the same time, daily, monthly, and yearly data, it's so easy because you have these existing packages and existing access points, right, like Yahoo Finance and Google Finance, that you can just download data in just one line of code, right? And here I just say a couple of packages that are very good for this: QuantMod, BatchGet Symbols, and TidyQuant. At the same time, if you have daily data, you can just change the frequency using DPIR, XTS, and data table if you need. So at the same time, when you work with high-frequency data, you have far more information, right? So from the research perspective, you're not looking into data, sample at defined intervals, right? So as an example, if you are looking at volatility, I never heard of anyone studying volatility at the yearly level. It doesn't make any sense, right? So as you decrease the frequency, you get far more information, and you reach the minimal point, which is tick-by-tick date. So the actual event, the financial event that we are modeling. So what happens is you have a version, what I call no pain, no gain, right? So if you want to have more quality in your research, then you need to go to a higher frequency. So why am I talking about that? I'm talking because basically what I wanted to do when I wrote this package, I want to get this point, the intraday point, as far as left to the possible. So if you are a rational researcher, right, you're going to maximize your utility by doing research on intraday data. So how do I do that? I wrote GateHF data as a simple package. I tried as much as possible to make it simple as possible. What it does is it accesses the Bovespa FTP site. So it's a package to download and aggregate high-frequency trade data from Bovespa, the Brazilian exchange. So what happened is I discovered that there was this almost hidden FTP site, which is public, and I just wrote an interface to it. So you can download data very easily, one line of code. You can choose the tickers, you can choose the dates, just like you do with QuantMod. And another great feature is that you have equity data, so spot market, and you also have derivatives, you have options, you have futures. So most of people here don't know this, but, well, at least for Brazil, but getting derivatives data in Brazil is very difficult. I try very different times, talk to different vendors, and if you're not willing to buy it, then it's you don't get it, right? So here is a quick example of how to use the package. You have a last date, you have a first date. So I'm downloading the last 90 days. And also you can choose if you want raw data, which is tick by tick, trade by trade, or if you want aggregate data like 5 by 5 minutes, 15 by 15 minutes, and so forth. Here in this example, I'm using some option contracts for Petrobras. So I have different strikes, I have different maturity dates. I'm not going to go into much the symbols, but each of those, besides P, T, R, they mean something, like the maturity and the, well, the strike price is very obvious. So you call the data, and this is an example of the output, a plot in ggplot. I'm sure that if you know a bit, but we are experiencing a lot of problems in Brazil, and these prices are likely to go down. These are call options, right? So the market has gone down yesterday a lot. And I have another example calculating volatility, but I'm just going to go forward and summarize is what are my next steps. I'm planning to implement order book data as well, so orders. This is going to be very soon. This will allow me to do more research in terms of the order book. I want to get an estimate of the order book by using this order data. Also interface better with high frequency, which is something I'm looking into it right now. And you can find more details about my package in my paper that I wrote in 2017. It's published already in the Brazilian Review of Finance. And just to finish, I have a book, and if you want to learn a little bit more about what I wrote, is just last month that I published it. The book is free, so everyone can access it or buy it if you want. Thank you so much. I have so little time, but thank you.
All right, so my name is Jeffrey Mazar. I'm here to talk about a package that I wrote with Brian called OB Modeling. And the idea behind this package was at work, working at DV Trading where I do prop trading. We were doing some analysis on level 2 order book data, and we found a lot of the packages that existed didn't use XTS, so it was hard to manage the time series data, and a lot of them were just focused on drawing pretty pictures and not doing a lot of analysis. So we're working on a package to do some more focus on analysis of order book level 2 data. I'm not going to talk through all of these, but these are some of the papers that we are have replicated or are working on replicating. to do more granular kind of tick-by-tick trade and quote data analysis for an order book. Here's an example of what it would look like to load the quotes and the trades data this is an example, some example data that we put in the package that's some futures from the E-mini. The OB modeling stores all this data in a environment, so it's pretty easy to get to if you want to through this get OB package. Right now, it just reads stuff from the Reuters data format, which is a pretty standard way for people getting historical level 2 data. As more people need different kinds of way of importing the data, or I figure out ways that Reuters isn't good enough, I'll add more ways. Here's an example of one of the functions that we wrote, the effective spread, which is, again, implementation of a paper. It's just the head of the output, and a lot of these functions have a store variable that if you set to true, it will store the results in the environment, so it'll make it easier to get to, so you don't have to keep passing this data around if you don't want to. Here's a list of the functions that we've implemented so far. A number of times the bid-ask changes, which is a measure of volatility, the effective spread, which I just gave an example, loading the trades, the quotes, some depth stats, some trade stats. The more interesting ones are the trade imbalance and VPIN. Those have a little bit more substance to them. Despite us making this package with the idea of focusing on analysis, we were not immune from drawing some pretty pictures. So here's a little, this isn't super pretty, but we're gonna make it prettier, of just drawing the depth of an order book at a given point in time. And one of the flaws of this is that it's just a single snapshot in time, so it doesn't really show you the evolution of the order book through time. But in the future, we're gonna work on drawing pictures that look more like this, which I guess is kind of hard to see in this chart, but this shows more of the order book evolution through time. You can kind of get the weighted midpoint as the line in the middle with the trades and the depth of the bid and the ask at various levels. We think that's pretty informative, but we haven't quite figured out how to make it draw that. This is the E-mini future. Yeah, oh, this I cited in one of the books at the end. You can talk after. So yeah, we thought those were good charts, and we wanted to draw them too as soon as we can figure out how to do it. And for future analysis, we found a paper on event analysis, so figuring out, defining when an event occurred, looking at historical data without actually having to know, what the news was at the time, and also coming up with some toxicity measures to trying to figure out how, if you were a market maker, how toxic this market would be to trade in. So you could find the package here on GitHub. You can install it through the dev tools. Please leave some notes or pull requests if you find something's broken, make issues. Anyway, thanks for your time. Here are the references. You can talk to me afterwards if you have more questions.
Good morning, everyone. My name is Yu Ting. I'm a PhD student at UIC. The topic of my research is return volatility, market microstructure noise, and institutional investors, evidence from high-frequency market. The objective of my research is to examine the role of institutional investors in the high-frequency world. We also took a look at mutual funds because mutual fund is one of the most important components of institutional investors. There is no doubt that institutional investors are important for the low-frequency movements of equity prices. However, the market is very different right now due to the development of technology. The stocks are traded more and more frequently, from a few transactions per day a couple of years ago to hundreds of transactions per second right now. So we would like to re-examine the impact of institutional investors on the market. One big challenge is that many estimators and measures developed from low-frequency data are no longer applicable in high-frequency world. For example, the volatility estimator. We used to have an old volatility estimator called the realized volatility. This is very popular and widely used. However, in concept, it should work well. But in reality, the price we observe is the true price plus a noise term. if we apply the old estimator to this observed price, it actually gives us the variance of the noise rather than the true integrated volatility. And this problem gets worse and worse if stocks are traded more frequently, as N will increase very fast. To solve this problem, we select the two scales estimator, also known as TSRV. The construction of this estimator is not complex. Here, the YYO is the old estimator, and the T is set for 1 day in this research. And the YY average is constructed by subsampling, say, every 5 minutes. Of course, you could choose other time intervals. We start subsampling from the first observation, then start with the second observation, and so on. The average of the results from all those subsamples is the YY average. Then we subtract the weighted YYO from YY average. The noise term is eliminated, and what left here is the true volatility of the return series. TSRV also provides a way to estimate the variance of noise. We just simply divide YYO by 2N. Now we just apply the TSRV estimator to our data. We collected data for Dow 30 companies, and from the tech database we get high frequency trades, the intraday millisecond trade information, and from CRSP we got some basic information of stocks, and from the Thomson Reuters we collected the ownership information. Here is the summary of the variables. The average of volatility is about 1.7 cents, and the median of institutional ownership is 65%, which means about 2/3 of the shares are held by institutions. All the individual investors around the world only possess 1/3 of the shares outstanding. And the mutual fund ownership varies from 8% to 42%. Then we just put all those variables into a linear regression model, and we find out institutional ownership has a positive relationship with volatility. That means if a stock being more possessed by institutional investors, the volatility of the stock would increase. And we also find a positive effect of institutional ownership on noise, which means they not only increase the volatility, but also increase the transaction costs of a stock. Since mutual fund is one of the most common institutional investors, we find similar results for mutual fund. The coefficients on mutual fund ownership are positive in both volatility model and in noise model. One more thing to pay attention here is that the Amihud variable doesn't work well in our research. Usually, the Amihud should be positively related to volatility and noise, but in our research, they are negatively correlated. One possible reason is that Amihud measure is not a sensitive measure for high-frequency data. If we compare the average Amihud value to the literature, our mean Amihud is much, much smaller than from the previous papers. So in conclusion, the institutional investors and mutual fund can positively affect the volatility and noise of stocks in the high-frequency market. Thank you very much.
All right, good morning, everyone. I want to talk to you today about broker execution. And what I really want to know when I start this project is what can broker execution tell us about microstructure? Because I really love microstructure and I don't have all the data necessary to like slice and dice every single trade at every single second. So I'm always looking for other ways of doing microstructure without like having a data warehouse in my home. I want to measure effective spreads, of course, but I'd also like to look at the likelihood of being routed out of the market center that your order ends up in. Because we know that being routed is probably going to result in a worse execution. So because I'm not a data scientist, I'm going to tell you my assumptions up front rather than come up with some assumptions after I do my model. I know, kind of a cheap shot. So Because my measurement is only on trades that execute within 30 minutes, I'm going to assume that there's no fundamental information that's coming out that's actually going to adjust our order book within that 30-minute time period. So I'm assuming that all of our decisions on whether or not we're going to execute or whether or not we're going to cancel or be routed or anything are coming from microstructure dynamics. And then secondly, I'm going to assume that there's actually competition between market centers, because if there's no competition between market centers and everybody has to trade on one particular venue, then there's no point in aggregating information across market centers along like date dimension or along our security dimensions. So where am I getting this data from? Reg NMS has Rule 605, which requires that all market centers put out a monthly report that tells us a little bit about how they execute their trades. So this is coming out on a monthly frequency, which may sound insane if you're thinking about microstructure on a monthly frequency, but everything is being measured as it occurs. So these are aggregated data. This is not just like taking an average. This is averaged by trade volume and by dollar value. It's segmented by ticker, by market center, and also by order type, which is really cool because now we can look at different types of orders, like the interesting folks who decide to put in a market order versus the people that use limit orders. All that stuff was compiled by the core group. So they were really nice in letting me use this data, because collecting this stuff by hand is absolutely insane. And market centers do not like to make it easy to let you find where all this information is. And there's some of the top ones will put it right out there, but when we start looking at our alternative trading venues, and they don't necessarily show up in a Google search. I'm going to combine that with our crisp CompuStat data, NICE TAC, and some optometric data, because I want to be able to control for different measures of volatility. So after that, my merged sample is only from 2007 to 2013. I have quite a few stocks, 75 market centers, and enough observations to where I can find something interesting. So I control for a couple of different stock factors, like pastor and standby liquidity, controlling just for return and turnover, and of course order type. And then I'm putting in some measures of volatility. And I really want to check what's going on with the order market share. So is there a different type of execution dynamics that's occurring for some venues that receive a lot of like retail order flow, or maybe some that receive limit orders that are submitted at the quotes as opposed to outside the quote? And then what, if any, impact do cancellations have on what's going on in each market center? So summary. For each market center, no surprise, market centers have vastly different execution quality. No surprise to people who work in industry, kind of a surprise if you think about it from a theoretical point of view. So if we have competition and at least a lot of people have the choice to move between market centers, why on earth do we not have spreads that are just going down to the minimum? We can look at maybe some of those liquidity kickbacks to figure out what's going on there, but I don't have that data. Market share matters, but not in the way that you might think. So venues that have a lot of market share, what I mean by market share is within each security, how many orders are you being submitted across, the market in this sense would be my entire sample of market centers. So the more market share you have in terms of orders being submitted, the wider your effective spread is. So something interesting is going on here in that you're getting best execution not on the top venues, but on these relatively small places that specialize in certain securities. Most trading venues have a significant reduction in effective spreads, so that's good. I mean, it would be terrible if we actually could show that there's a lot of bad actors out there, but for the most part, most market centers are doing what they ought to be doing. But there's maybe about 12% of market centers that are actually specifically making your execution worse. And we can actually show that on, with statistical significance. There tend to be more smaller spreads on market centers with more canceled orders. And if we look at retail order flow, so what I use for retail order flow is market orders, because I'm assuming that no professionals are submitting market orders. But market orders tend to have a significant impact on our spread. So I'm looking, I guess I'm out of time now. Awesome. Okay. So I have some interesting findings on routing too. But if you're at all interested in working on broker execution, please let's talk later on in the conference. Thank you very much.
Thank you. So the title of my presentation is How Can Machines Learn to Trade? I won't be talking about any specific machine learning paradigm. What I want to talk from a very high level is about how we can improve machine learning process through using ensembles and shrinkage of parameters, but just to illustrate it on very simple methods. This didn't come out very well. Okay, the graphic isn't visible. So the major technique in machine learning is backtesting or cross-validation. The idea is we train the model on historical data and we test it out of sample. And the critical parameter is the look-back window. How long do we look into the past to train the model? The longer we look into the past, the lower the variance. But we also risk, am I doing something wrong? Yeah, there was a graphics here, but that's fine.
Okay.
For the
Okay, if that's fine. Okay.
yeah. Thank you. So let's start with a very simple problem, namely choosing a skilled manager from among managers who have no skill. So if we think about a skilled manager has a Sharpe ratio, excess Sharpe ratio of 0.4, then the probability of him making the right call on a daily basis is about 51.2%. So very, very small edge is enough to create a excess Sharpe ratio of 0.4. So the model that we can use, that we can think of, is coin flipping. So let's imagine we have a biased coin of with a 60% probability of heads, and how many times do we have to flip it to distinguish a biased coin from unbiased coins? So we can think of a manager with skill as a biased coin with more probability of heads than tails. And it turns out it actually takes quite a bit of coin flips, 132 coin flips, to get to a 95% confidence level. With the managers, it would take 33 years of historical data to distinguish a manager with skill from managers without skill, given a Sharpe ratio of 0.4. So probably by the time we decide, okay, that manager has skill, he's close to retirement. The problem becomes much worse if we have many managers. So if you look at the number of managers, instead of just distinguishing between two managers, if we have many managers, we're facing the risk of p-hacking, meaning just purely by chance, one manager without skill can outperform a manager with skill. So that's why the performance of our strategy of manager selection goes down. So here's the effect of number of managers on our P&L. How to counteract that? We just increase the look-back period. So we look back into the past for a longer period of time, and lo and behold, our strategy improves. But the problem with that is that we don't have that luxury in finance, right? So we have a limited amount of data. So what I've done is I've created another model to illustrate this problem. So we have the sign represents the drift or the skill. So the skill is time dependent. We have several managers and their skill changes with time. And our task is to catch the manager with outperformance skill versus all the other managers who have no outperformance skill. And the graphic is missing. I'm sorry about that, but somehow the HTML did not render properly. I'll just have to describe it. And hopefully you'll be able to download the correct version from the website. We have several choices we can just trend follow, meaning we choose the best manager from the past and select them and own them out of sample in the future. And that doesn't work very well. There's no graphics, but it doesn't work very well. An even better method is select the 2 top managers. So we're reducing our variance by averaging out our bets. And we're also, here's where the shrinkage comes in. So there's an ensemble because we're effectively averaging over 2 strategies, but we're also shrinking the weights of our model because we are betting on the outperformance of 2 different managers, not just one. So we're not 100% weight on one manager is 50-50. For example, if we have two top managers. And the long-short ensemble or momentum or relative value is when we go long the top manager and short the bottom manager. And that is it's a well-known technique from financial markets, the momentum. And that also has the advantage of reducing the variance and increasing the signal-to-noise ratio. So I apologize for not showing the graphics. They were supposed to illustrate this. You can download the presentation. It's on GitHub. Thank you very much.